Hello everyone. So today we are going to solve LeetCode today's problem of the day 1015. Okay. So the question is smallest integer divisible by k. In this we have an integer k and we need to find the length of smallest positive number n such that n is divisible by k and n only contain digit 1. What it mean, like n only contain 1. That means it can be 1 1 1 1 1 1 1 1 1. In the similar this way go, and we have to find out which one is the smallest, okay, which is divisible by k, and we have to return the length. And if we can't find, then we are going to return -1. Okay, so if you see like k is 10 to the power 5 and all, so we will later go to adjust all the things, but initially we will think like how we approach this problem. Okay, so we know our first task is how we get this sequence, like one later 1 1 then 1 1 1. So suppose if we declare our num with 0. Okay, uh, if we declare our num with 0, okay, and we are going to do num equal to num into 10 plus 1. Okay, right? So what it is going to do, so if it is 0 to 0 into 10, 0 0 plus 1 1. Okay, now num become 1. Okay, so 1 into 10 10, 10 plus 1 11, num become 11. 11 into 10 110 plus 1 1 1 11. Okay, now num become 111. So if we multiply by 10, then it's become 1110 plus 1 this one. So similarly with this we can get this sequence now. Okay, if we get this sequence, so the things is like we are going to check if that is divisible by k. So okay, if not divisible by k, then -1. So like, okay, I'm going to write the code, and whenever we get issue, then we will think. Okay, right? So like, our num is 0 and we are going to do these things, and up to when. Okay, so suppose where is a while loop, this is true. This true means like if we don't find the number, that means here we are returning -1, this condition would be not there, but we are going to write like it is currently for true. Okay, until we find. So this num equal to, this num become num into 10 plus 1. Okay, now what is our work? If okay, num modulus k, okay, equal to 0, that means this, but we have to return length, I think. Yeah, we have to return length, so we can also declare a length variable, int length equal to 0. And whenever we multiply, that means whenever we get the next number, we are going to increase the length. Okay, so if this one, then we are going to return length. Okay, okay, so this should work, but not always. Like if it is not divisible by k 2 3 7. Okay, this one. Okay, so if we remove this test case, okay, now run. Okay, now whatever the issue, if we add a test case like 2. Okay, so 2, so we know, uh, okay, we know like we are going to get the number like 1 1 1 1 1 1 1 1 1 1. So it's always 1 at the unit place, so it is not going to divide by 2. So it's going to still search, and it would be get in TLE, like if you see. Okay, sure. Yeah, TLE. Okay, sorry, I said TLE. It means like it is going to get doing the things, and this num get overflow. Okay, now, so how we can do the things? Okay, like how we can. Okay, one things I want to explain you. First things, like they have said, okay, this is another thing. They said like 10 to the power 5 is there. If we take long, I think we can go up to 10 to the power 30. That means 30 digits and all. So we have to think something else, like mod. Okay, mod and all. So how we are going to do that? So we will see now. Okay, so suppose what we say, I will take an example. Okay, and for that example I have written some things from that I am going to explain, so that you have a better idea. Okay, so this is okay. Now suppose k is 7. Okay, we are going like 1 1 1, then 1 1 1, then 1 1 4 1, then 5 1, in this way. And I have also calculated modulus of 7, that is going to give 1 4 6 5, and these are the modulus value. Okay, now if okay, so yeah, before seeing this one, let's see this one. When we multiply, because how we are getting 1 from 1 1, then 1 1 1, by multiplying by 10 plus 1, right? Okay, so n into 10 plus 1. Okay, now suppose our n is 4 1 1 1 1 1. Okay, so h, okay, we can put this in the form of 7k plus p, where 7k total is the all the number which is which would be divisible by 7. 7k means a number, and that p is remainder. It's something like what we said, a number can be written in the form of this k is constant and this p is remainder. Okay, so this can be written as 7k plus p, where 7k are the number sections which is divisible by 7, and this p are the extra number, or we can say remainder. Okay, so now the next number will become n into 10 plus 1, that means 7k plus p into 10 plus 1. So this becomes 70k plus 10p plus 1. Okay, if we see that this 7k initially was the other things other than the remainder, now that becomes 70. Whatever the any factor that like 10 would get multiplied later, it would become 700 or whatever the things. So this 70, if this 7k is divisible by 7, then 70k must be. So we are just forwarding it, and it's of no use, because the things that are contributing in the remainder is 10p plus 1. And how we are getting this 10p plus 1? This is nothing that but the 10 into the remainder plus 1. Okay, I think you're clear. Let me explain again. If here n, we have arranged the n in the form of 7k plus p. Okay, now that 7p into 10, okay, that is always going to give you the remainder 0. Okay, so that means that are not going to affect anything. So we are not going to deliver, we are not going to forward this 7k to the next, right? So this 7k we are not passing, we are just passing the remainder, and we are going to multiply that remainder into 10 plus 1. Okay, that is coming here as 10p plus 1, right? This one. Okay, so now this 7k is irrelevant to us, and this is creating also the issue of overflow. So we are going to, because if we see this remainder is p, and finally we are also getting 10p plus 1, right? Okay, this is also written the same as the remainder into 10 plus 1. Okay, now if we see from this, okay, this 11 modulus 7 is 4, so like 1 into 7 plus 4 is there. Okay, now if we say this one, so this one is 11. Okay, in this way, and if we think that 7 into some n and 1 plus k is there. Okay, so now what we are going to do, we are just going to keep the remainder and going to make that into 10 plus 1, because the rest one are already divisible by 7. If we multiply by 10 also, then also that is going to divisible by 7. We are just carrying it, that is of no use now. Okay, one more thing is there which we come on later, but what we now think, like, okay, whatever this num is, we are just multiplying by 10 into 1, but we can do the, okay, modulus, take mod. What is the mod? Into mod equal to k, whatever our number is, because we are going to divide that by k. Okay, so this one mod. Okay, so now, okay, now one thing is there. Now what we did, we, okay, now if we think about the k is 10 to the power 5, so mod okay, so if we do the mod of any number with this is going to be less than. That means now we are not going this issue, that is signed integer overflow. Okay, so but still we get some issue. What is the issue? Like when it is going to divide by 2, okay, so it's not get overflow, but it is not getting the answer also, and it is going to go, and it is going to give you the TLE. Let's see. Yeah, okay, TLE. Now how can, because if the number, if you are if k is 2, we are going to find a number divisible by 2, but always 1 1, then 1 1 1, then 1 1 1. So in this way, so that is no. So how we can think? Okay, if see, when we see, if suppose k is 7, again we come on notes. Okay, now if we came on 7, okay, k equal to 7, so what the remainder, like 1 4 6 5 2 0 and 1. Okay, so whenever we get remainder equal to 0, okay, okay, in the sorry, okay, whenever the remainder is 0, that means this is we got, okay, and this whatever the this one, that's it, that is answer, and we can calculate and return the length. Okay, first things now. Okay, so what we need to change in the code is first, like, now we are not going to check, we are just going to check that whether this num is 0. If this is 0, we are going to return length. And in the last case is also like, if we are not getting return, but if we are not coming here because of this true, because we are not getting, so we are not coming out. Okay, so okay, now that means we have to somewhere remove that, we have to somewhere remove this true with some things. Okay, and we know if k is 10 to the power 5. Okay, so what this number modulus mod give, this is like 0 to 10 to the power 5 minus 1, right? Okay, so how many possible values for num is there? So whatever, so that is the value of k. Okay, that means k got excluded, but 0 will come, so 0 to k minus 1. Okay, now why? Okay, now the question should be, okay, suppose if we write like here k minus minus, okay, that means we are going to run this k times. Okay, k means 0 to k minus 1. Okay, uh, okay, so if we are going to run this k times, that means this is going to give some remainder k times. Okay, so and we know the maximum remainder is that means maximum number of remainder. The number of remainder means like 0 to k minus all this number. If we k, if like, if always the different remainder came also, there's only k opportunities, so we go like. And what the next things is like, if we can't get 0 in this, because if k options are there and in among k there is a 0, if we still don't get 0, that means some part is repeating. Okay, this thing. Okay, like if we see these things, okay, in this like 7 is there, so actually what are the options for remainder? 0, 1, 2, 3, 4, 5, 6. The first it came 1, then 4, 6, 5, 2, then it came 0. So here we get our answer, and suppose if this is not 0, in the next step if we get 1. Now if we get repeating 1, then it's again going to repeat the same things which we don't want, which is going to create the TL. Okay, right? So like if we take k equal to 8, like 1, then 3, then 7 again, that means whenever the remainder repeat, that means it is going to do again the same cycle. Okay, like if this is not 0, okay, and this is some other value like 3 and all, so this is going to again give the same one and need to go in cycle, like similarly here. Okay, so this will be cycle and repetition causing the TLA. So the reason behind, okay, so the reason behind taking here k is we have only possible 0 to k minus 1. If we get k chances and still we don't get, that means some number is getting repeated. Okay, so we are, that means we are not getting any zero. Okay, because if we get 0, we might have returned from here, and we take all the k, we check all the k, we are not getting 0, that means some value is repeating. Okay, I think you are clear. Okay, now, okay, now if we run, okay, so now the same thing here, this is k times. Okay, now if we run, if we submit, this will be submitted, but the basic idea we can think of like some things, because if we check like 2, okay, k is 2, okay, k is 2, or k, that means 1 1 is there, like 1 1 1, and that is unit digit 0, that is neither divisible by 0 nor 5, because sorry, neither divisible by 2 nor 5. Why not 2? Because for 2 divisible by 2, this should be at unit digit, it can't be 1, and for also 5, it should be either 0 or 5. Okay, so we can just check on, so that it will escape, like if k, okay, if k modulus 2 equal to 0, that means if k is divisible by 2, that means k can't divide it, or k, okay, k modulus 5 equal to, just it's for escape we can remove all also this, so this is going to return -1, so that we, okay, whatever the number is there, is just going to improve our like code, because whenever the k is divisible by 2, that is we are not going to find it. And even for the case of 5 also, if we run, And if we submit, okay, okay. Now if we talk about the complexities, we have not used any space, yeah, but one loop is there which is going to iterate our k times. So this is our big of k or big of an operation. Thanks for watching.